Hi, this is a submission of Team Astrobugs, and we are excited to walk you through our project on Kubernetes failure prediction using AI. The system begins with a Kubernetes cluster running real workloads. We use Prometheus in kubectl using Minikube to continuously scrape metrics from the pods and deployments like CPU usage, memory consumption, and container restarts. These real-time metrics are fetched by a Python backend, which pre-processes the data. That includes handling missing values, smoothing noisy data using rolling averages, and generating failure flags. Note that the data is scraped using Prometheus every 5 minutes to increase accuracy and the depth of the data. So if you want to train the model, a better model will be trained if you run the Prometheus for a long time. We have trained our data on a really smaller version of the data, but then it can be improved. So every time the test and train accuracy of the model will be different, but we have ensured that the model is accurate and does not have overfitting. The model predicts if there's a failure, after which we are post processing the model and generating failure flags based on dynamically calculated thresholds. The metrics are passed to the trained model that we built and optimized. It is using the random forest method. Now that the model is trained, when a potential failure is detected, we use Google Gemini API with prompt engineering to generate actionable remediation steps. For example, it might suggest rolling back a deployment, restarting a pod, or scaling resources. We use Python's K8 client to make these remediation steps work in the Kubernetes clusters in real time. To make the system usable in real-world environments, we deployed the model using Fast API, which serves as a REST endpoint. The API receives metrics as input and responds with failure prediction and suggested fixes. The whole system is containerized and deployed. We've also created a Streamlit-based web UI where the user can monitor predictions in real time and chat with a Gemini-powered AI chatbot. Now, the additional feature of our whole project is a Gemini powered AI chatbot to ask questions related to the failure or the metrics. Now, this has also undergone prompt engineering for it to not work like a general chatbot and instead work just to answer queries related to the failure and or the metrics. Coming to the system diagram, the Kubernetes clusters running overloads the Prometheus scrapes pod and deployment metrics. The Prometheus is running inside the Kubernetes. Then the Python backend fetches and pre-processes the metrics, and then it goes to the ML model, which suggests remediation. The Python backend, which fetches the metrics, also goes to the Python. Has a Python backend in which the fast API exposes these metrics to the front end Streamlit UI, where the user can track the metrics in real time. The ML model suggests remediation, and then which is post processed using threshold and failure flags. And then we have used the Gemini API, and then Gemini suggests remediation. All of this comes together in Streamlit UI, and also a chatbot for the user to ask queries. The architecture ensures observability, intelligence, and usability, all integrated into a single pipeline. You can view the deployed chatbot and documentation using the links in our README. We have created a very detailed README with all of the information regarding our projects to guide you through it. Thank you.